NEC Article 300.9 requires electrical conductors to be protected from physical damage by using the appropriate wiring methods and materials. NEC Article 352.10 requires raceways and enclosures to be of suitable type for the environment they are installed in, which includes protection from corrosion, weather, and physical damage. NEC Article 410.32 B requires enclosures installed outdoors to be weatherproof. The use of exposed NM cable and standard electrical boxes is not suitable for use in the exposed and potentially corrosive environment of a post and beam building with a wood truss roof. Rigid NM conduit and wet location boxes are necessary to provide the required protection from physical damage and corrosion. The cost difference is justified by the increased safety and reliability they provide. The consequences of non-compliance include electrical shock or fire hazards, damage to electrical equipment, voiding of insurance coverage, and fines or penalties from the electrical inspector. To elaborate on the NEC requirements and ensure compliance, firstly, Article 300.9 is fundamental. It emphasizes that all electrical conductors must be adequately protected from physical damage. This is not merely a suggestion, but a strict requirement designed to prevent accidental damage to the wiring, which could lead to short circuits, electrical shocks, or fires. The type of protection required depends on the environment and the expected level of physical stress. For example, in areas where the wiring is exposed to heavy machinery or foot traffic, more robust protection methods, such as rigid metal conduit, may be necessary. Secondly, Article 352.10 broadens this requirement by specifying that raceways and enclosures must also be suitable for their environment. This means that they must be able to withstand the conditions to which they are exposed, including corrosion, weather, and physical damage. The choice of materials is critical here. For instance, in a damp or corrosive environment, enclosures made of stainless steel or PVC may be necessary to prevent deterioration and maintain electrical safety. The term raceway refers to any channel designed and used expressly for holding wires, cables, or bus bars. Raceways can be made of metal or insulating material, and examples include conduits, tubing, and cable trays. Thirdly, Article 410.32. These specifically addresses enclosures installed outdoors, mandating that they be weatherproof. This requirement is particularly important in areas subject to rain, snow, or other forms of precipitation. Weatherproof enclosures are designed to prevent water from entering and damaging the electrical components inside, which could lead to equipment failure or electrical hazards. In the context of a post and beam building with a wood truss roof, the environment is often considered exposed and potentially corrosive. This is because the wiring is not concealed within walls or ceilings, and it may be subject to moisture, dust, and temperature fluctuations. Therefore, the use of exposed NM cable and standard electrical boxes is generally not permitted under the NEC. NM cable, or non-metallic sheath cable, is commonly used for residential wiring in dry locations. However, it is not designed to withstand the harsh conditions found in exposed environments. Standard electrical boxes, which are typically made of steel or plastic, may also be vulnerable to corrosion and physical damage. To comply with the NEC and ensure the safety and reliability of the electrical system, it is necessary to use rigid NM conduit and wet location boxes. Rigid NM conduit is a type of raceway that provides excellent protection against physical damage and corrosion. It is typically made of galvanized steel or PVC and is available in various sizes to accommodate different wiring configurations. Wet location boxes are designed to prevent water from entering and damaging the electrical components inside. They are typically made of weatherproof materials and have gaskets or seals to create a watertight barrier. The cost difference between using standard wiring methods and using rigid NM conduit and wet location boxes may seem significant. However, the increased safety and reliability they provide justify the investment. By using the appropriate wiring methods and materials, it is possible to prevent electrical shocks, fires, and equipment damage. It is also possible to avoid voiding insurance coverage and incurring fines or penalties from the electrical inspector. Non-compliance with the NEC can have serious consequences. Firstly, electrical shock or fire hazards are a primary concern. Damaged or improperly installed wiring can create a risk of electrical shock, which can be fatal. It can also create a risk of fire, which can cause extensive property damage and endanger lives. Secondly, damage to electrical equipment is another potential consequence. Exposure to moisture, corrosion, or physical damage can cause electrical equipment to fail prematurely, resulting in costly repairs or replacements. Thirdly, voiding of insurance coverage is a significant risk. Insurance companies may refuse to cover losses resulting from electrical fires or other incidents if the electrical system is not in compliance with the NEC. Fourthly, fines or penalties from the electrical inspector can be substantial. The electrical inspectors are responsible for enforcing the NEC, and they have the authority to issue fines or penalties for violations. In summary, continuing with the current wiring in a post and beam building with a wood truss roof would be a violation of the NEC. Rigid NM conduit and wet location boxes are necessary to provide the required protection from physical damage and corrosion. The cost difference is justified by the increased safety and reliability they provide, and the consequences of non-compliance can be severe. It is always advisable to consult with a qualified electrician to ensure that the electrical system is installed in accordance with the NEC and local codes. This helps to ensure that the electrical system is safe, reliable, and in compliance with all applicable regulations. Furthermore, let's delve deeper into the specific requirements and recommendations for wiring in such environments. Firstly, understanding the applicable NEC articles is crucial. Beyond the previously mentioned articles, other sections of the NEC may also be relevant depending on the specifics of the installation. For example, Article 310 addresses conductors for general wiring, and it provides guidelines on ampacity, insulation, and other factors that can affect the performance and safety of electrical wiring. Secondly, selecting appropriate wiring methods is paramount. While rigid NM conduit is a good option, other types of raceways may also be suitable depending on the application. For example, electrical metallic tubing, or EMT, is a lightweight conduit that is often used in commercial and industrial buildings. However, EMT is not as strong as rigid NM conduit, and it may not be suitable for areas where the wiring is exposed to heavy physical stress. Thirdly, choosing the right type of electrical boxes is equally important. Wet location boxes are designed to prevent water from entering and damaging the electrical components inside. They are typically made of weatherproof materials and have gaskets or seals to create a watertight barrier. However, there are also other types of electrical boxes that may be suitable for certain applications. For example, weatherproof boxes are designed to withstand exposure to the elements, but they are not necessarily watertight. Fourthly, proper grounding and bonding are essential for electrical safety. Grounding is the process of connecting electrical equipment to the earth, which provides a path for fault current to flow back to the source. Bonding is the process of connecting different metal parts of the electrical system together to create a low impedance path for fault current. Proper grounding and bonding can help to prevent electrical shocks and fires. Fifthly, regular inspections and maintenance are necessary to ensure the continued safety and reliability of the electrical system. Electrical systems should be inspected regularly by a qualified electrician to identify any potential problems. Maintenance should be performed as needed to keep the electrical system in good working order. Sixthly, considering the specific environmental factors is crucial. In a post and beam building with a wood truss roof, the wiring may be exposed to a variety of environmental factors, including moisture, dust, temperature fluctuations, and corrosive substances. It is important to select wiring methods and materials that are able to withstand these conditions. Seventhly, ensuring proper installation techniques is paramount. Even the best wiring methods and materials will not be effective if they are not installed properly. It is important to follow all applicable codes and standards when installing electrical wiring. Eighthly, documenting the installation is important for future reference. It is a good idea to keep a record of all electrical work that is performed, including the date, location, and description of the work. This information can be helpful for troubleshooting problems in the future. Ninthly, staying up to date on the latest codes and standards is essential for electrical safety. The NEC is updated every 3 years, and it is important to stay informed of the latest changes. There are many resources available to help electricians stay up to date on the NEC, including training courses, seminars, and publications. Tenthly, seeking professional guidance is always advisable. If there are any questions or concerns about electrical wiring, it is always best to consult with a qualified electrician. A qualified electrician can assess the situation and provide recommendations on the best way to ensure electrical safety. In addition to these specific recommendations, there are also some general principles that should be followed when installing electrical wiring. Firstly, always work safely. Electrical work can be dangerous, and it is important to take precautions to protect yourself from electrical shock. Always turn off the power before working on electrical wiring, and use appropriate safety equipment, such as gloves and eye protection. Secondly, follow all applicable codes and standards. Electrical wiring must be installed in accordance with all applicable codes and standards, including the NEC and local codes. Thirdly, use high-quality materials. The quality of the materials used in an electrical installation can affect its safety and reliability. Always use high-quality materials that are approved for use in electrical wiring. Fourthly, perform thorough testing. After the electrical wiring is installed, it should be tested thoroughly to ensure that it is working properly. Testing can help to identify any potential problems before they cause a safety hazard. Fifthly, maintain accurate records. Accurate records of the electrical installation can be helpful for troubleshooting problems in the future. These records should include the date of installation, the location of the wiring, and the types of materials used. By following these recommendations and principles, it is possible to ensure the safety and reliability of electrical wiring in a post and beam building with a wood truss roof. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if there are any questions or concerns. Furthermore, let's discuss the specific types of wiring and conduit that are suitable for different environments. Firstly, understanding the different types of NM cable is crucial. NM cable, or non-metallic sheath cable, is commonly used for residential wiring in dry locations. However, there are different types of NM cable that are designed for different applications. For example, type NMB cable is the most common type of NM cable, and it is suitable for use in dry locations. Type UF cable, or underground feeder cable, is designed for use in wet locations and underground. Secondly, exploring the different types of conduit is also important. Conduit is a raceway that is used to protect electrical wiring from physical damage and corrosion. There are different types of conduit that are designed for different applications. For example, rigid metal conduit, or RMC, is the strongest type of conduit, and it is often used in commercial and industrial buildings. Electrical metallic tubing, or IMT, is a lightweight conduit that is often used in commercial and industrial buildings. Flexible metal conduit, or FMC, is a flexible conduit that is used to connect electrical equipment to a power source. Thirdly, considering the environmental factors is paramount. When selecting wiring and conduit, it is important to consider the environmental factors to which the wiring will be exposed. For example, if the wiring will be exposed to moisture, it is important to use wiring and conduit that are designed for wet locations. If the wiring will be exposed to corrosive substances, it is important to use wiring and conduit that are made of corrosion-resistant materials. Fourthly, following the NEC guidelines is essential. The NEC provides guidelines on the types of wiring and conduit that are suitable for different applications. It is important to follow these guidelines to ensure that the electrical wiring is safe and reliable. Fifthly, consulting with a qualified electrician is always advisable. A qualified electrician can assess the specific environment and provide recommendations on the best types of wiring and conduit to use. In addition to these specific considerations, there are also some general principles that should be followed when selecting wiring and conduit. Firstly, always use high-quality materials. The quality of the materials used in electrical wiring can affect its safety and reliability. Always use high-quality materials that are approved for use in electrical wiring. Secondly, ensure proper installation techniques. Even the best wiring and conduit will not be effective if they are not installed properly. It is important to follow all applicable codes and standards when installing electrical wiring. Thirdly, perform thorough testing. After the electrical wiring is installed, it should be tested thoroughly to ensure that it is working properly. Testing can help to identify any potential problems before they cause a safety hazard. Fourthly, maintain accurate records. Accurate records of the electrical installation can be helpful for troubleshooting problems in the future. These records should include the date of installation, the location of the wiring, and the types of materials used. By following these recommendations and principles, it is possible to ensure the safety and reliability of electrical wiring in any environment. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if there are any questions or concerns. Let's explore some additional aspects of electrical safety and compliance. Firstly, understanding the importance of overcurrent protection is critical. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical wiring and equipment from damage caused by excessive current. When an overcurrent occurs, these devices automatically interrupt the flow of electricity, preventing overheating and potential fires. Secondly, recognizing the significance of ground fault circuit interrupters, or GFCIs, is essential. GFCIs are designed to protect people from electrical shock. They monitor the flow of current in a circuit and quickly interrupt the power if they detect a ground fault, which is a leakage of current to ground. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electrical shock. Thirdly, implementing proper wiring practices is paramount. Proper wiring practices include using the correct wire size for the circuit, making secure connections, and protecting wires from damage. Improper wiring practices can lead to overheating, electrical shorts, and potential fires. Fourthly, conducting regular electrical inspections is crucial. Regular electrical inspections can help to identify potential problems before they cause a safety hazard. Electrical inspections should be performed by a qualified electrician. Fifthly, staying informed about electrical safety is essential. Electrical safety is an evolving field, and it is important to stay informed about the latest codes, standards, and best practices. There are many resources available to help people stay informed about electrical safety, including training courses, seminars, and publications. Sixthly, understanding the specific requirements for different types of occupancies is important. The NEC provides specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. These requirements are designed to ensure the safety of people and property in each type of occupancy. Seventhly, following manufacturer's instructions is paramount. Electrical equipment should always be installed and used in accordance with the manufacturer's instructions. Failure to follow the manufacturer's instructions can lead to equipment damage, electrical shock, or fire. Eighthly, avoiding overloading circuits is crucial. Overloading a circuit can cause the wiring to overheat and potentially start a fire. It is important to avoid plugging too many appliances or devices into a single circuit. Ninthly, being aware of the signs of electrical problems is essential. There are several signs that may indicate an electrical problem, such as flickering lights, burning smells, and sparking outlets. If you notice any of these signs, it is important to have the electrical system inspected by a qualified electrician. Tenthly, taking action to correct electrical problems is paramount. If an electrical problem is identified, it is important to take action to correct it as soon as possible. Ignoring electrical problems can lead to more serious problems, such as electrical shock or fire. By following these recommendations and principles, it is possible to ensure the safety of electrical systems. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if there are any questions or concerns. Also, understanding the different types of electrical enclosures is critical for ensuring safety and compliance. Firstly, NEMA ratings define the environmental protection provided by electrical enclosures. The National Electrical Manufacturers Association, or NEMA, has established a rating system that classifies electrical enclosures based on their ability to protect against various environmental conditions such as dust, water, and corrosion. Secondly, UL listings indicate that an enclosure has been tested and certified for safety. Underwriters Laboratories, or UL, is an independent organization that tests and certifies electrical products for safety. A UL listing indicates that an enclosure has been tested and found to meet certain safety standards. Thirdly, enclosure materials play a crucial role in their performance. Electrical enclosures are typically made of metal or plastic. Metal enclosures are generally more durable and provide better protection against physical damage, while plastic enclosures are lighter and more resistant to corrosion. Fourthly, enclosure size is important for proper ventilation and wire bending space. Electrical enclosures should be sized appropriately to provide adequate ventilation and wire bending space. Overcrowding an enclosure can lead to overheating and difficulty making connections. Fifthly, access and maintenance should be considered when selecting an enclosure. Electrical enclosures should be easily accessible for inspection and maintenance. The enclosure should also be designed to allow for easy replacement of components. Sixthly, specific enclosure types are suited for different applications. There are many different types of electrical enclosures, each designed for a specific application. Some common types of enclosures include junction boxes, pull boxes, and control panels. Seventhly, hazardous location enclosures are required in areas with flammable materials. In areas where there is a risk of explosion or fire due to the presence of flammable materials, hazardous location enclosures are required. These enclosures are designed to contain any sparks or explosions that may occur inside the enclosure. Eighthly, grounding and bonding are essential for safety. Electrical enclosures must be properly grounded and bonded to ensure electrical safety. Grounding and bonding provide a path for fault current to flow back to the source, which helps to prevent electrical shock. Ninthly, regular inspections and maintenance are necessary. Electrical enclosures should be inspected regularly to ensure that they are in good condition. Any damage or corrosion should be repaired promptly. Tenthly, consulting with a qualified electrician is always advisable. Selecting the appropriate electrical enclosure for a particular application can be complex. It is always best to consult with a qualified electrician to ensure that the enclosure is suitable for the environment and the electrical equipment that it will house. By understanding the different types of electrical enclosures and their applications, it is possible to ensure the safety and reliability of electrical systems. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if there are any questions or concerns. Furthermore, consider the implications of using the wrong type of wiring or conduit in a specific application. Firstly, using NM cable in wet locations can lead to electrical shock or fire. NM cable is not designed for use in wet locations, and it can quickly deteriorate if exposed to moisture. This can create a risk of electrical shock or fire. Secondly, using EMT in areas with heavy physical stress can result in damage and failure. Electrical metallic tubing, or EMT, is a lightweight conduit that is not designed to withstand heavy physical stress. Using EMT in areas where it is likely to be damaged can lead to wiring failures and potential safety hazard. Thirdly, using undersized wiring can cause overheating and fires. Using wiring that is too small for the circuit can cause the wiring to overheat, which can lead to a fire. It is important to use the correct wire size for the circuit to ensure that it can safely handle the current. Fourthly, using improper connections can lead to loose wires and arcing. Improper connections can lead to loose wires, which can cause arcing and potential fires. It is important to make secure connections using the appropriate connectors. Fifthly, neglecting to protect wiring from physical damage can result in shorts and electrical hazards. Wiring that is not protected from physical damage can be easily damaged, which can lead to shorts and electrical hazards. It is important to protect wiring from physical damage by using conduit or other protective measures. Sixthly, failing to ground and bond properly can create a shock hazard. Proper grounding and bonding are essential for electrical safety. Failing to ground and bond properly can create a shock hazard. Seventhly, ignoring signs of electrical problems can lead to serious consequences. Ignoring signs of electrical problems, such as flickering lights or burning smells, can lead to more serious problems, such as electrical shock or fire. It is important to have electrical problems inspected and repaired promptly. Eighthly, performing DIY electrical work without proper knowledge can be dangerous. Electrical work can be dangerous, and it is important to have the proper knowledge and training before attempting to do it yourself. It is always best to consult with a qualified electrician if you are not comfortable performing electrical work. Ninthly, neglecting to update electrical systems can lead to safety risks. Electrical systems can become outdated and unsafe over time. It is important to have electrical systems inspected and updated as needed to ensure that they are safe and reliable. Tenthly, failing to follow codes and standards can result in fines and legal issues. Electrical work must be performed in accordance with all applicable codes and standards. Failing to follow codes and standards can result in fines and legal issues. By understanding the potential consequences of using the wrong type of wiring or conduit, it is possible to avoid these risks and ensure the safety of electrical systems. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if there are any questions or concerns.